We're the Disease Busters. I'm Lynn. I'm an immunologist and virologist.
Steph, microbiologist.
Carl, an epidemiologist.
And I'm Andy, a public health official.
Today we're going to talk to you about antibiotic resistance in North America, and we have a case study from the famous YouTube vlogger Becca Travels. Here's her story.
Hey guys, it's Becca, your favorite YouTube vlogger. Today's destination is Phoenix, Arizona. We just landed a couple hours ago. We're here for Lindsay's 22nd birthday, and I can't wait to share with you guys our adventures. We went to Scottsdale for Lindsay's 22nd.
Happy birthday!
Woo! What club did we go to?
Pancake. Cake, silly.
It was pretty good, good vibes, had some drinks. We went out for dinner. Okay, so we just got to Lindsay's apartment and we're waiting for her to get back from work. Hopefully we'll make the basketball game tonight. I definitely want to see the boys play. Hey!
Hey guys, how's it going?
How's your shift, Lindsay?
Good. It was so long, super busy, but good to be back.
Alright, so I'll let you guys know how the game goes. Recap of the weekend. So we went out to Scottsdale, had some dinner at what's it called?
Culinary Dropout.
Culinary Dropout. It was pretty good. Some good vibes. There's some live music.
Really good food and drinks.
Today we're just hanging out at the pool,
Poolside.
resting. Check out the pool.
Recovering, resting. Our girl's over there. If you can't
Guys, so it's Valentine's Day. Happy Valentine's Day.
Happy Valentine's Day.
We're here at Hole in the Rock in Phoenix, Arizona, just checking out the sunset. Last day in Arizona. Dree's gonna get a tattoo today, right, Dree?
Yeah.
I apologize for my rasp voice. I'm getting a little bit sick. All right, we'll show you that tattoo.
Johnny dang on my wrist.
Go! All right, last day in AZ.
Bye!
Hey guys, so I just got home. Arizona was a blast. I definitely would do it again. The weather was great, the food was great. Obviously the people I went with were the best people to go with. I'm clearly not feeling very well. Gotta hit up the doctor, maybe grab some antibiotics for this cold. So until next time, make sure you subscribe to Becca Travels down below. See ya. Hey guys, it's Becca from Becca Travels. Today's vlog is not going to be my normal traveling videos. I wanted to inform you guys on something that recently happened to me. So after I came back from Phoenix, I thought I had a cold, but really I was in the hospital for about 3 weeks. The doctors prescribed me with multiple different types of antibiotics and my body was just resisting all of them. I had this bacteria in my body called Klebsiella Pneumonia, and I think I picked it up from Lindsay. So since I don't have too much knowledge on it, I decided to join a Disease Busters team, and they're here today to inform you guys more about it. So here's the Disease Busters team. My name is Dr. Lukakis. I am a microbiologist. I study microscopic organisms that causes diseases. I'm here today to inform you about the bacteria Klebsiella that causes respiratory infections. Firstly, bacteria is a microscopic organism that is unicellular, and this bacteria can either be harmful or beneficial to the body, harmful in ways that it can cause diseases or even death. Klebsiella is a gram-negative type of bacteria that is non-motile, lactose fermenting, and rod-shaped. It is associated with respiratory infections as well as bloodstream, surgical, urinary infections, also known to cause meningitis. Pneumonia is a type of infection that causes the lungs, specifically the air sacs, to inflame with fluids. This causes symptoms such as cough with phlegm, fever, chills, difficult breathing. Klebsiella pneumonia is a direct contact infection to the respiratory tract that is spread from person to person. This particular bacteria is a facultative anaerobic organism. This means that this particular bacteria can grow and survive with or without the source of free oxygen. Some virulence factors that aid the bacteria in antimicrobial resistance are capsular polysaccharides, lipopolysaccharides, O side chains, and capsular antigens. Capsular polysaccharide, also known as CPS, is the outer capsular layer of the bacteria that contains polymorphonuclear cells. The capsule protects the bacteria against phagocytosis by acting as a barrier between the receptors from the macrophages and the bacterial binding sites. Lipopolysaccharide O side chains, also known as LPS, contains lipid A, core, and O polysaccharide antigens. It contributes to the structure of the bacteria itself and resists the processes by human immune systems to kill the bacteria. Capsular antigens are composed of complex acidic polysaccharides and is also an essential factor of virulence. This gram-negative type of bacteria has developed antibiotic resistance. Antimicrobial resistant organisms, also known as superbugs. This occurs when a bacteria or other types of microorganisms undergo spontaneous genetic mutations when they are exposed to antibiotic treatment. This makes the treatment ineffective and the infection still present, making it available to spread within the body or to others who are susceptible. Antimicrobial resistance interferes with the effectivity of prevention and treatment of infections caused by bacteria. Not only are these types of organisms difficult to treat, but they can also pass their genetic traits to other bacteria in the body, making them resistant as well. This currently increasing antimicrobial resistance to antibiotics is a risk to the public globally, but specifically in this study, North America.
Hello, I'm Coral. I'm an epidemiologist, and today we'll be talking about antibiotic-resistant bacteria. And bacteria we're focusing on is Klebsiella pneumoniae. So people use the term superbug to describe this bacteria, and what they mean by that is that it is a bacteria that has become resistant to the antibiotics that are usually used to treat it. So in this case, we're talking about different kinds of penicillins like ampicillin and carbenicillin. And it is estimated now that approximately 74% of pneumonia diagnoses result in a prescription from a healthcare professional. So what exactly is Klebsiella pneumoniae? It is a bacteria that was discovered by German physician and bacteriologist Edwin Klebs. It is the leading cause of both community-acquired and hospital-acquired pneumonia. It's also what we call an opportunistic pathogen. Normally, people can live with this bacteria without experiencing any symptoms. However, when there is a disruption of the normal flora of bacteria in the body, K. pneumoniae can progress into a severe bacterial infection. We'd also like to know who's most at risk. So the Federal Health Agency of Canada has found that risk of infection and carriage rates increase with increased duration of stay in the hospital. Approximately 140,000 healthcare-associated infections and 600 deaths occur annually in the United States alone. Something else people will need to know is how it is spread. So the bacteria are not airborne, so you cannot contract the infection by breathing in the same air as an infected individual. K. pneumonia is spread through direct person-to-person contact, so it can be spread if someone with contaminated hands touches an open wound or from infected medical equipment such as catheters and breathing tubes. As epidemiologists, we need to know why antibiotic resistance is such a big concern to the treatment of this particular infection. The bacteria has now become resistant to several strains of antibiotics, including penicillins and now carbapenems, which are usually considered to be a last resort drugs. And these trends are very concerning for epidemiologists because although there are several bacteria that are becoming antibiotic resistant, there are fewer and fewer new antibiotics being created. Out of 18 of the largest pharmaceutical companies, 15 have now abandoned research on antibiotics. It's important for the general public to know that antibiotic-resistant bacteria do not solely affect those who have overused antibiotics. Anyone can contract an antibiotic-resistant bacteria, and that is why this is such an important public health issue.
Hi again, I'm Dr. Hsci. I'm an immunologist and virologist, and my role as a disease buster is to discover how the immune system works and how we can combat the crisis of antibiotic resistance in North America. To begin, I'll talk about the immune system. As human beings, our immune system is actually a very adaptive system that consists of many specialized cells. This includes T cells and B cells. They differentiate into different kinds of cells that will directly attack pathogens that enter our bodies. They have various mechanisms on how they attack pathogens, and one of those mechanisms is the production of antibodies. Antibodies are proteins that float around in our bloodstream, and they can attack any kind of foreign invaders that come into our system. Antibodies are very specific, and they'll only target specific pathogens because they have unique binding sites. As we know that antibodies are one of the primary defense systems of our body, we can actually use them to our advantage when it comes to antibiotic-resistant bacteria. Either synthesize antibodies or isolate them from other species, and we can actually inject a serum that will go into an infected patient, and they'll help the patient recover in what's called antibody therapy. Actually, antibody therapy is more of a supplementary therapy rather than a replacement for antibiotics. Because of this, we have to look for other alternative solutions. An alternative solution that is being considered is the bacteriophage therapy. Although it's not widely researched in Canada and the USA, it is widely researched in Russia. In Russia, they're taking advantage of viruses that infect only bacteria, and they're highly specific. In this way, they can introduce a variety of phages into a patient, and at least one of them might have a chance of targeting the bacteria that's pathogenic. They're actually using the virus to kill the bacteria with no harm to the host whatsoever. In addition, there's no harm to the host's microbiota. As it turns out, bacteria are actually a very important part of every human being's immune system, as they reside in the gastrointestinal tract of every human being. They actually provide a barrier between the cells of your gastrointestinal lining and between other pathogens that might come into contact with them. In addition, they actually help stimulate the T cells involved in a host immune system. This leads to the problem of antibiotic resistance in North America. Because our society is so reliant on antibiotics, it actually turns out it's doing more harm than good. Every time you take antibiotics, it's not only killing the pathogens that it's targeting, but it's also killing a number of the beneficial bacteria that live inside of your gut. After you take antibiotics, your immune system is actually compromised because there's no longer bacteria living in there that actually help your immune system. When the numbers of beneficial bacteria in your gut have decreased due to antibiotics, it actually makes way for the bacteria that were resistant to the antibiotic to thrive. This contributes to the increased numbers in harmful bacteria that are resistant to the antibiotic, and they can further multiply and spread their genes. As an immunologist and a virologist, I find the spread of antibiotic-resistant pathogens to be very concerning. Therefore, we need to educate the public and stop the misuse of antibiotics in order to really prevent the spread of antibiotic-resistant bacteria.
Hi, my name is Antibiotic, Public Health Official for the Center of Disease Control. I'm here to inform the public of a disease strain that has been spreading in North America and to give information on antibiotics. My role is to present information on the following public health issue in an appropriate manner that can be easily interpreted by the public. The disease is K. pneumonia, a respiratory infection causing superbug. Risk factors include age, sex, and alcohol use. Infants, seniors, and males are at high risk for contracting K. pneumonia. In addition, overuse of alcohol is a preventable risk factor for the infection. This type of infection caused by K. pneumonia usually occurs among patients who receive treatment from devices like breathing machines or catheters, and also among patients who have been treated with antibiotics for long periods of time. Patients who have been introduced to long periods of multiple different antibiotics increase susceptibility to infection and also are at a higher risk of contracting the disease. Healthcare workers can be exposed to disease by their patients and spread the bacteria to another patient by not washing their hands in between patients. In the case of Becca from Becca Travels, a nurse was exposed to disease at the hospital she worked at, which led to her first possible exposure to K. pneumonia when she drank from the same water bottle as her. The disease was then able to be passed to her friends that visited for her birthday from Vancouver, which they then exposed to others on the plane and family and friends back at home, causing the initial spread of a pandemic of K. pneumonia. There has been a high prevalence of cases found in Australia, South Asia, South America, and South Africa. Also, regions known to have a high number of HIV cases that are susceptible to high rates of K. pneumonia because the virus is significantly associated with HIV infection. Therefore, travelers in these regions should be wary of possibly contracting the virus. The public is urged to be very cautious as the particular strain is known to show resistance to penicillins. Infants, seniors, and those living in crowded conditions are particularly susceptible to the virus and should look out for the following symptoms. Symptoms include fevers, chills, and leukocytosis with red currant jelly-like septum, which is a mixture of saliva and mucus coughed up by the respiratory tract. If you experience any of these symptoms, be sure to see a doctor right away and take proper steps to tackling the infection. In general, avoid contacts with others at all costs. To stop spread of this antibiotic-resistant strain, be sure to know when it's appropriate to use antibiotics. Antibiotics are used for bacterial infections, not viral infections. Misuse of antibiotics accelerates the natural process of antibiotic resistance. In particular, make sure you use your entire prescription. To prevent infections, wash hands before preparing or eating food, touching open body parts like your eyes, nose, and mouth, after using the restroom, and before and after touching any sort of bodily fluids, such as coughing or sneezing. In addition, ask a doctor if antibiotics are appropriate for your case and stay at home when you're sick. If you have further questions regarding antibiotic resistance, be sure to visit dobugsmedrugs.org.